So we've spent some time working with segments and congruent segments and midpoints of segments and lengths of segments. Today and next time we are going to focus on angles instead. So let's go ahead and jump in. Some of this stuff you already know, but some of it might be new, or might be new terms for things that you already understood. Or maybe we'll go deeper on something that you have covered before. So an angle is formed by two rays that have a common endpoint. The rays are called the sides, and the endpoint is called the vertex of the angle. So if you look at this figure, the vertex is point A. So vertex is always a single point, and the sides are ray AC and ray AB. Sides of an angle are always rays, even if the figure doesn't draw them as rays. So like if you had a square, FGHI, we've got an angle in here, angle, this angle right there. Its sides are ray FG and ray FI, even though those are segments, not rays. We still think of them as rays, because angles, like rays, extend forever in the direction they go. Now, we name rays. We have several different ways, or not rays, we name angles with several different ways. We could call this angle A. This is going to come as a shock, but the symbol for angle is a little angle. Okay, we could call this angle A using just the vertex. Now that one can be tricky because you can't always use that one. We could name it using 3 points. A point on one side, the vertex, and then a point on the other side. So this could be angle CAB or angle BAC. Notice in both of those, vertex is in the middle. And then sometimes, if there's a little number inside that angle, then we could call this angle 3. Oftentimes when you have figures that have lots of angles in them, they will be numbered, so that way it will be easier to tell which angles are what, and it'll be easier to write their names down. Now, going back to the fact that we can call this angle A, but if you look at the figure below, we can't call this angle X, and here's why. I'm going to draw this out, but then I'm also going to erase it and then work with the work through the example. But we can only use a single letter when there's just one angle at that point. So if we look at this figure, well, I've got an angle here that has X as a vertex. I've got an angle down here that has X as a vertex. And I've got this big angle that has X as a vertex. So all of those have X as a vertex. So if I write angle X, I don't know which one I'm talking about. So I would want to use angle WXY or WXZ or YXZ. Can't use just angle X. All right, and I actually just named the 3 angles in this diagram. WXY, that's this one. YXZ, that's this skinny one at the bottom. And then WXZ, that's the whole thing. So those are our 3 angles. Now, angles are measured in degrees. You may already know that. We would say the measure of angle WXZ is 32 degrees. I don't know if that's true. I did not measure this. The symbol we use for degrees is just like the one you use for temperature degrees. It's just the little o, but it is raised as a superscript, kind of like an exponent. If we wanted to write this out, this would be the measure of angle WXZ equals 32 degrees. So when we want to talk about the actual measurement of an angle, we have that M in front of it. Okay? If there's no M in front of it, it's talking about the picture. If there is an M, it's talking about how many degrees there are. And just like we had the ruler postulate for segments, we have the protractor postulate for angles. And it basically says that we are allowed to measure angles. We have a way to do that. And for those of you who don't know what a protractor is, on the back page of your notes, that's a protractor. It allows you to measure angles. You would put one side of the angle down here and have the vertex right there where H is. And then wherever the other side of the angle is, in this case right here, that's the measure. So that angle right here would be 125 degrees. We'll come back to that in class if we need to. Alright, two angles are congruent if their measures are equal. So we would say the measure of angle C equals the measure of angle D. But then we could say angle C is congruent to angle D. So if you're going to use an equal sign, you need that M. If you're going to use a congruent sign, you don't need the M. And we put marks on angles just like we do for sides when they're congruent, only the little arcs inside the angle. So you can look here and see that angle S and T are congruent because both of those have one arc. Then angles P and R are congruent to each other because both of those have two arcs. Now this part should be review. Classify angles based on their measures. Acute angles. Okay. The measure is less than 90 degrees. So anywhere from 0.1 degree up to 89.9 degrees. We won't really have decimals in our degrees most of the time. But if it's less than 90, then it is an acute angle. A right angle, the measure equals 90 degrees. And we denote that with the perpendicular box. Okay, that little box, remember, tells us you have a right angle. It tells you the measure of that angle is 90 degrees. That means those two rays are perpendicular. So remember, when you have perpendicular lines, they form right angles. We'll come back to that when we do parallel and perpendicular lines. An obtuse angle, the measure is between 90 degrees and 180 degrees. So it's bigger than a right angle, but it doesn't go past 180 degrees. And remember, 180 degrees is straight across. That's actually our next angle. The measure is exactly 180 degrees. That makes it a straight angle. So you might not have seen straight angle before, and you were probably taught obtuse is greater than 90. But obtuse is greater than 90, but less than 180. So just make sure you put that distinction in your brain. Tuck it away somewhere. Alright, so for example 3, we want to classify these angles. Most of the time, you will classify them based on what they appear to be. I'm not going to give you a protractor to do it every time, but in this case we do have a protractor. So GHL, that's this angle. Okay, and we can see that one is 90 degrees. So that is a right angle. KHG. That comes down here and then goes this way. That's the one we actually did a little bit ago. That's 125 degrees. It's greater than 90, less than 180, so that's obtuse. KHJ comes down there but then goes this way. Now when the angle's on that side, we'd be using these inside numbers because it's going to start at 0. But that one is 55 degrees, that's less than 90, so that's acute. And then GHJ goes straight across the bottom here, 180 degrees, that is a straight angle. Now, just like with segments, we had segment addition, to where we could add two segments together to get the whole thing. We have angle addition postulate. And this says, if point, it got erased, if point P is on the interior of angle RST, then RSP plus the measure of PST equals the measure of RST. That basically means if we've got two angles that we call them adjacent angles that butt up to each other, have the same vertex, and share one of their sides where my thumbs are, then this angle plus this angle equals the whole thing. So small angle plus small angle equals the whole thing. I'm going to write it down like that. Small angle plus small angle equals whole thing. Now, especially with your angles, it's going to be helpful for you to write out a setup line. And I'll do that on here. It's very helpful to have that so that you know you are plugging things in the right spot. Example 4. Given that LKN, that's this whole thing, and oftentimes we'll draw a big arc right there, and that tells us that whole thing is 145 degrees. Find X and the measures of both smaller angles. So, just to color code it a little bit, I'm going to have a red angle, a green angle, and orange is the whole thing. So the red angle is called LKM. The green angle is MKN, and the whole thing is LKN. Now notice each of these has the M in front of it because these are measures. These represent numbers. They're kind of like variables. We can't add and subtract pictures. We can add and subtract numbers. So for LKM, that's one of our small angles. We know that's 2x plus 10. MKN, we know that is 4x minus 3. I kind of covered it up there. Let me double check. Yes, 4x minus 3. And we know the whole thing is 145. So now it's just a, it's kind of a multi-step equation. Oh, well, it is a multi-step. So the first thing we need to do is combine like terms. So I've got a 2x plus a 4x, that's 6x. And then I've got a plus 10 and a minus 3, so that's plus 7. And then the other side hasn't changed. So I want to subtract 7 from both sides. So that's going to give me 6x equals, and then 145 minus 7 is 138. And then we'll divide both sides by 6. So x will be 23. So this tells us find x. So we found x. It also tells us to find both of the smaller angles. So to do that, we're going to plug x back in. Let me section this off. So for our red angle, the measure of angle LKM equals 2 times 23 plus 10. Let me clean that up. So that means 2 times 23 is 46 plus 10. So LKM is 56 degrees. And then for our green angle, I'm going to write it on the far left just because I've run out of space. The measure of angle MKN is going to be 4 times 23 minus 3. 4 times 23 is 92. And 92 minus 3 will be 89 degrees. So X was 23, and then our red angle LKM was 56. Our green angle MKN was 89. If we wanted to check our work, we could say 56 plus 89. That is going to give us 145. So we know we did it correctly, or we got really lucky. All right, last concept for today. An angle bisector is a ray that divides an angle into two congruent angles. So it splits the angle in half, just like a midpoint kind of splits a segment in half. A midpoint has to be a point. An angle bisector has to be a ray. So anytime you see angle bisector, you know your two angles are congruent, your two small ones. Anytime you see two small angles like that that are congruent, like in this example, we know that we have a segment or an angle bisector. So in this diagram, TW bisects XYZ, and that should be YW, a little typo on my part. The measure of XYW is 18 degrees. Let's label that in our picture. Find XYZ. So we want to find the whole thing. Well, if XYZ, our red angle here, is 18, what is WYZ? I think I said that wrong. XYW is 18, so what is WYZ? They're congruent because we have a bisector, so that also has to be 18 degrees. Now, even though this is a much simpler problem than the last one, I'm still going to write out my setup. So small angle XYW plus small angle WYZ equals whole thing, the big angle XYZ. We know that the measure of XYW is 18, which means WYZ is also 18 because they are congruent, because we have an angle bisector. And so we could add those two together, and we know that 36 degrees is the measure of angle XYZ. Now, just like with segment addition, you could have just multiplied by 2, but the fact that you can do that is based on angle addition. So, angles have a lot of similarities with segments in the things we can do with them, but we classify angles based on their measures, which we can't do with segments. But we can add them together. We have bisectors. So there you go. That's your introduction to angles. We'll do more with angles next time. So make sure you fill out the Google form and get ready for your practice problems. Good luck.